Hello dear students. In this video, we will discover the fascinating world of electricity. We'll learn about how electric current flows, the difference between conductors and insulators, and the basics of electric circuits. Let's start with conductors. Conductors are materials that let electric current flow through them easily. Think of them like highways for electricity. Metals such as copper, silver, and aluminum are great examples of conductors. These materials have unique properties that allow electric charges to move freely. Now, let's talk about insulators. Insulators are materials that do not allow electric current to pass through easily. They act like barriers to electricity. For instance, wood, plastic, rubber, and glass are common insulators. Insulators are very important. They help keep us safe from electric shocks. That's why electrical wires are covered with insulating materials like rubber or plastic. When we use devices like phones or lamps, we plug them in to get electricity from a power source, like a power station. This flow of electricity is known as electric current. You can think of it as a stream of tiny particles called electrons moving through wires. Electric charges are of two types, positive and negative. Positive charges are found in protons, while negative charges are carried by electrons. In an electric circuit, electrons travel from the negative side of a power source to the positive side. We measure electric current in a unit called ampere, often shortened to A. The ampere tells us how much charge flows through a conductor in a set amount of time. More charges mean a higher current. Now, let's talk about electric circuits. An electric circuit is a path that allows electric current to flow in a loop. It includes components like bulbs, batteries, switches, and wires. For the current to flow, the circuit must be closed, meaning all components are connected. The direction of electric current can be a bit tricky. Electrons actually move from the negative terminal of a battery to the positive terminal. However, by convention, we say the current flows from the positive to the negative terminal. Next, let's discuss voltage or potential difference. Voltage is the push that drives electric charges through a circuit. It's measured in volts, V, and can come from batteries, generators, or other power sources. In a circuit, current moves from a higher voltage point to a lower voltage point. When we create or read circuit diagrams, we use electric symbols. These simple drawings represent different electrical components and help us understand and design circuits more easily. Speaking of components, an electric cell is one of the key players. It turns chemical energy into electrical energy. It has two terminals, one positive and one negative. The chemical reaction inside generates the electricity that powers the circuit. There are different types of cells. Primary cells are used only once. Once they're drained, they can't be used again, like the batteries in remote controls. On the other hand, secondary cells can be recharged and used multiple times, like the batteries in our smartphones. Next, let's discuss an electric switch. An electric switch is an important component that controls the flow of electric current. When the switch is on, the current flows. When it's off, the current stops. Another important part of the circuit is the electric fuse. It protects the circuit from overload by breaking the circuit if too much current flows, which helps prevent damage. And then we have the electric bulb. When current passes through its filament, the filament heats up and glows, producing light. When it comes to electrical circuits, there are different types. In a series circuit, components are connected in a single path. If one part fails, the entire circuit stops working. In a parallel circuit, components are connected side by side. If one part fails, others can still work. This is how our home circuits operate, allowing different devices to function independently. Electric circuits can be designed in different ways. It's essential to understand how they work. Now, here is a question for you. In a conventional electric circuit, from which terminal to which terminal does the current flow? Please share your answer in the comments. The complete curriculum for Class 7 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.